The Navy's ambitious fleet size expansion relies upon a massive increase in heavily armed destroyers able to launch long-range attacks, fire interceptor missiles, defend carrier strike groups and engage in massive open blue water warfare. Within the next 15 years, the Navy plans to add as many as 30 DDG-51 destroyers, including 22 new, high-tech DDG-51 Flight III warships and 8 state-of-the-art DDG-51 Flight IIA destroyers. Prioritizing such a large number of these warships offers an interesting analytical window into Navy thinking about the next 5 decades of ocean war. In addition to adding 30 new destroyers, the Navy also seeks 15 LCS, 18 of the new frigates and as many as 32 new attack submarines in the next 15 years. While many new ships are now under construction, the current number of Navy ships is roughly in the high 280s, a number the Navy hopes to grow to 355 by 2034. Battle force inventory reaches 301 in 2020 and 355 in 2034, LT. CMDR Kevin Chambers, told Warrior Maven. Adding large numbers of new next-generation destroyers will substantially change the Navy's ability to conduct major maritime warfare operations by enabling surface forces to detect enemy attacks at much farther distances, launch long-range strikes with greater precision and destructive force and disperse offensive forces across much wider swaths of ocean. The U.S. Navy has awarded deals for 10 new high-tech DDG-51 Flight III destroyers and built-in options to add even more ships and increase the build rates for construction of new warships. Meanwhile, the Navy has already started construction on its first new Flight III DDG-51 surface warfare destroyer armed with improved weapons, advanced sensors and new radar 35 times more sensitive than most current systems, service and industry officials explained. Navy Flight III destroyers have a host of defining new technologies not included in current ships such as more onboard power to accommodate laser weapons, new engines, improved electronics, fast upgradable software and a much more powerful radar. The Flight III destroyers will be able to see and destroy a much wider range of enemy targets at farther distances. A new software and hardware-enabled ship-based radar and fire control system, called Aegis Baseline 10, will drive a new technical ability for the ship to combine air warfare and ballistic missile defense into a single system. The AN Spy-6 radar, also called Air and Missile Defense Radar, is engineered to simultaneously locate and discriminate multiple tracks. This means that the ship can succeed in more quickly detecting both approaching enemy drones, helicopters and low-flying aircraft as well as incoming ballistic missiles. The Raytheon-built AN Spy-6 radar is reported by developers to be 35 times more powerful than existing ship-based radar systems. The technology is widely regarded as being able to detect objects twice as far away at 1/2 the size of current tracking radar. The farther away ship commanders can see approaching threats, across the spectrum of potential attack weapons, the faster they are able to make time-sensitive decisions about which elements of a ship's layered defense systems should be used. The AN Spy-6 platform will enable next-generation Flight III DDG-51s to defend much larger areas compared with the AN Spy-1D radar on existing destroyers. The AN Spy-6 is being engineered to be easily repairable with replaceable parts, fewer circuit boards and cheaper components than previous radars, according to Raytheon developers. The new radar is also designed to rely heavily on software innovations, something which reduces the need for different spare parts. Service officials say the new ship uses newly integrated hardware and software with common interfaces will enable continued modernization in future years. Called TI-16, Technical Integration. The added components are engineered to give Aegis Baseline 10 additional flexibility should it integrate new systems such as emerging electronic warfare or laser weapons, according to a Navy announcement in early 2018. Last year at the Surface Navy Association, the ship's program said that special technological adaptations are being built into the new, larger radar system so that it can be sufficiently cooled and powered up with enough electricity. The AMDR will be run by 1,000 volts of DC power. The AMDR is equipped with specially configured cooling technology. The Navy has been developing a new 300-ton AC cooling plant slated to replace the existing 200-ton AC plant, Navy developers have said. Before becoming operational, the new cooling plant will need to have completed environmental testing which will assess how the unit is able to tolerate vibration, noise and shocks such as those generated by an underwater explosion, service officials said. Through the course of several interviews, SPY-6 radar developers with Raytheon have told Warrior Maven that simulated weapons engagements have enabled the new radar to close what's called the track loop for anti-air warfare and ballistic missile defense simulations. The process involves data signal processing of raw radar data to close a track loop and pinpoint targets. Raytheon developers said the radar works by sending a series of electromagnetic signals or pings which bounce off an object or threat and send back return signal information identifying the shape, size, speed or distance of the object encountered. The development of the radar system is hastened by the reuse of software technology from existing Navy dual-band and AN and TPY-2 radar programs, Raytheon developers added. As a result, it is entirely plausible that AMD or a comparable technology will be engineered onto amphibious assault ships, cruisers, carriers and other platforms as well. Raytheon statements say AN SPY-6 is the first truly scalable radar, built with radar building blocks, radar modular assemblies, that can be grouped to form any size radar aperture either smaller or larger than currently fielded radars. Raytheon data on the radar system also cites a chemical compound semiconductor technology called gallium nitride which can amplify high-power signals at microwave frequencies. It enables better detection of objects at greater distances when compared with existing commonly used materials such as gallium arsenide, Raytheon officials explained. Raytheon engineers tell Warrior that gallium nitride is designed to be extremely efficient and use a powerful aperture in a smaller size to fit on a DDG-51 destroyer with reduced weight and reduced power consumption. Gallium nitride is a much higher breakdown voltage so it is capable of much higher power densities. Raytheon developers said the DDG Flight 3s will also be built with the same Rolls-Royce power turbine engineered for the DDG-1000, yet designed with some special fuel efficiency enhancements, according to Navy information. DDG-51 Flight 3 destroyers are expected to expand upon a promising new ship-based weapons system technology fire control system, called Naval Integrated Fire Control, Counter-Air, or NIFC-CAR. The technology, which has already been deployed, enables ship-based radar to connect with an airborne sensor platform to detect approaching enemy anti-ship cruise missiles from beyond the horizon and, if needed, launch an SM-6 missile to intercept and destroy the incoming threat, Navy officials said. Navy developers say NIFC-CA presents the ability to extend the range of attack missiles and extend the reach of sensors by netting different sensors from different platforms, both sea-based and air-based together into one fire control system.